Mapping the brain at scale today involves a massive intersection of wet lab biology, high-resolution imaging, and artificial intelligence. Research hubs are being built specifically to manage this complexity. At Stanford's Woodside Neurosciences Institute, bioengineers and data scientists work alongside clinicians in the same laboratory spaces. Other global hubs, like the Gatsby unit at UCL, focus on the intersection of computational theory and biology, building mathematical models of how neural circuits actually process information. Because of these resources, a single research paper is now expected to synthesize multimodal data, combining animal behavior, high-density electrophysiology, and machine learning models to support its claims. In this new environment, isolated findings from a single experiment struggle to gain traction. To influence the field, your work has to prove its relevance across different layers of analysis. While the pace of discovery has accelerated, the traditional academic publishing system remains remarkably slow. The shift toward interdisciplinary work has created a reviewer bottleneck. Finding experts qualified to vet a study that spans 3 or 4 different subfields often causes extreme delays in the peer review process. This creates a direct conflict with the career timelines of researchers. A typical PhD or postdoc contract is a 4-year window, but the time required to publish in high-impact venues is steadily climbing. When peer review drags on for 12 to 18 months, you hit a crisis point. The review process can literally outlast your funding or your degree timeframe. This forces a difficult choice. You can hold out for a prestigious journal and risk a multi-year revision cycle, or you can opt for a faster, specialized publication to keep your career moving. Making the wrong choice here can stall your momentum. Strategic journal selection has become a vital skill for anyone trying to navigate a career in neuroscience. The first option is the Tier 1 elite generalist journals, such as Nature Neuroscience or Neuron. These require a massive input, years of data, and a comprehensive level of mechanistic detail that answers every potential reviewer question up front. The outcome is wide-reaching visibility. These journals carry the prestige needed to secure major institutional grants and reach the largest possible audience across the field. But the trade-off is it helps the lab's long-term funding, but it puts a heavy burden on the individual researcher's immediate career timeline. The second path involves high-impact specialized journals, like the Journal of Neuroscience or Biological Psychiatry. The input here is a complete mechanistic story that stays focused on one subfield. You aren't pressured to prove broad, cross-disciplinary significance. This offers a major speed advantage. You typically get a first decision within 30 to 60 days, and your work is read by the specific peers who understand your niche. Acceptance rates are much more realistic here, often ranging between 15 and 40%. The trade-off is visibility outside your specialty. A Tier 2 paper is respected, but it may not carry the broad weight needed to anchor a massive interdisciplinary grant on its own. For most working neuroscientists, this tier is the pragmatic choice. It builds your reputation in your subfield and keeps your career moving. Then there is the third path, the open access and preprint ecosystem, including platforms like eLife or bioRxiv. You bypass initial peer review delays by uploading work directly to servers. However, fully open access journals often require high article processing charges to cover publication costs. The outcome is immediate. Your work is out in the public. You establish priority on your discoveries, and you satisfy the open access mandates required by most major funders. Because these papers have a DOI immediately, you can list them on job and grant applications months before the formal review process even finishes. The primary trade-off is the loss of traditional prestige markers that older hiring committees may still value, and the publication fees move directly onto your lab's budget. This model shifts power away from legacy publishers. It prioritizes the speed of scientific communication over the slow accumulation of prestige. To find the right strategy, you have to match these paths to your specific career constraints. For a PhD student or postdoc with limited funding, the time-poor trainee path is usually the safest. Prioritize Tier 2 journals and use preprints. This ensures you have a citable paper ready for the job market, without the risk of a multi-year review loop. Computational researchers moving into neuroscience face a different hurdle. They often find open access and computation-heavy journals a better fit. Because computational work can be misunderstood by traditional reviewers, platforms with transparent review models are often more effective. Principal investigators with long runways and consistent funding are best positioned to pursue the Tier 1 strategy. The right journal choice depends entirely on which career milestone you need to hit next. Regardless of your career stage, the ultimate tool for managing risk is the cascade strategy. You start by submitting to a high-tier journal, but you have your backup targets ready. If you get a rejection, you submit to the next journal on your list the very same day to maintain your momentum. Lab leaders can use this to absorb the risk for the lab while protecting their trainees, ensuring that narrower methodological work is published in lower tiers so people can graduate on time. A long-term career in neuroscience is built on a diverse portfolio of work across different tiers, not a single lucky break. Using this publishing playbook allows you to reclaim your time. When you stop worrying about the system, you can focus on the work that actually matters, understanding how the brain works.